First, ocean heat can be converted to electrical energy, limiting sea level rise. Second, seawater can be desalinated and used to irrigate the world's hot deserts, thus drawing down the volume of water in the ocean. And finally, part of the ocean's liquid volume can be converted to the gases oxygen and hydrogen, with the first replenishing the ocean's dead zones and the latter forming the basis of the hydrogen economy. It is also argued in this presentation irrigated deserts and revitalized phytoplankton habitats can reverse, that is, mitigate the buildup of carbon dioxide in the atmosphere that is the cause of climate problems in the first place. Mitigation is the process of reducing greenhouse gas or removing them from the atmosphere, as with carbon sinks, such as irrigated deserts and vital phytoplankton. Some researchers have concluded that in the absence of some form of mitigation, climate change effects will reach a magnitude where adaptation by some natural systems will be impossible. For humans, the economic and social costs will also be high. The UN Framework Convention on Climate Change has estimated annual global costs of adapting to climate change are between 40 and 170 billion US dollars, or the cost of about 3 Olympic Games per year. A study by the scientists from the International Institute for Environment and Development and the Grantham Institute for Climate Change at Imperial College London determined that the real cost of adaptation are likely 2 to 3 times greater. The study found that the mean net present value of climate change impacts in one scenario is $1,240 trillion with no adaptation and only $890 trillion with adaptation. In the aggressive abatement case, where carbon levels are maintained at less than 450 parts per million, the mean net present value of climate change impacts is only 410 trillion, or 275 trillion with adaptation. So stabilized at 450 parts per million with a conservative mitigation effort reduces net present value impacts by $615 to $830 trillion, but the abatement NPV cost is only 110 trillion, or a saving of 6 to 1 or better. It is likely most of this cost is going to be avoided entirely by an aggressive mitigation approach herein proposed, because not only can OTEC produce all of the energy mankind needs, currently a $4 trillion a year enterprise, irrigated deserts would also generate revenue to offset the cost of their environmental remediation. Some have argued OTEC cannot produce more than 5 terawatts annually rather than the 60 terawatts Smalley advocates, but the fallacy of this argument is addressed in the third installment of this series. As there are patent issues involved, the means to accomplishing the gain cannot be revealed at this juncture. For those who argue we cannot afford to tackle the climate problem, the argument is obvious. World military expenditures in 2009 were estimated at $1.531 trillion, or 2.7% of world GDP, or approximately $225 for every person on Earth.